CodeWright has been developed for the solution of geotechnical engineering problems. Sebastián Olivella, myself, Alfonso Rodríguez Dono, and Jan Bonat, we are the CodeWright team, and in this presentation, Erdem Toprak, Xavier Pintado, and Ivan Puig-Damians are researchers that have contributed to the work presented here. CodeWright solves the questions that are summarized in this transparency, which include mass balance, energy balance, and momentum balance. There is a set of quantitative equations and equilibrium restrictions, and I can mention ideal gas for the properties of fluids, Bank-Newton for the unsaturated response of porous materials, Fourier for heat conduction, Darcy for fluid flow, and Fick for diffusion and dispersion mass transport. A number of mechanical constitutive equations have been implemented in the code. They are for rocks and soils, and include very specific features that are investigated in the laboratory. And for instance, give solution for unsaturated behavior of materials, thermal effects, hardening, softening, etc. This is how CodeWright looks like in the GID environment. Specific windows have been developed for the specific features of CodeWright, and it's important to highlight that for material properties we have a number of constitutive equations and parameters available in the interface. CodeWright has a web page in which you can find material for the self-learning of the program use, and this material includes tutorials for beginners and tutorials for advanced users. We work in spent fuel disposal. It's a problem that different countries face. Is related to the generation of energy with the nuclear power plants, and the waste that is generated has to be stored and just isolated. And one of the solutions that is proposed is the underground disposal, and here that's a representation of the underground disposal in the rock. That's something that is a work we carry out for agencies of nuclear waste disposal, in this particular case for Posiva in Finland, but we also work for SKP in Sweden, Andra in France, GRS in Germany. These four companies or institutions give support for the development of CodeWright. The multi-barrier system is based on the idea that the isolation is guaranteed by several components. We investigate the geological materials, which are the host rock and the clay-based engineered barrier. This is an example of the type of models we develop. You see here the drift, a vertical borehole, waste installed in it, and the different components, and in this case the temperature that develops due to the remaining power in these spent fuel components. It's not only temperature but also fluid flow and deformation. Here you can see the liquid pressures developed in the system as water flows from the rock and tries to fully saturate the material. At the same time, a swelling pressure develops because the clay-based materials are highly expansive. These are the type of materials we investigate. Clay-based materials, in this case it's powder or pellets. We do laboratory work, and then we use some models and develop them in terms of calibrating the response of these materials for loading, hydration, and so it's a full mechanical, hydraulic, and thermal characterization of the material. You can see in this case the sample shows indication that it was originally made with pellets, and then the pellets have expanded and this more uniform structure has developed. We use the constitutive equations and the approach to model larger scale schemes. In this case, it's for a laboratory, for an in situ laboratory. In this laboratory, there are different drifts in which they are vertical boreholes. The vertical boreholes are intended for installing not directly nuclear waste, but heaters that simulate the nuclear waste, and then all the thermo, hydro, and mechanical processes can be investigated in situ. Measurements are made, and the models that can predict the evolution of as I said, temperature, pressures, displacements, stresses, etc. The model in this case is not sufficiently detailed in the zone of interest of the barrier, so normally we can do other type of models, and this is a more detailed model for the zone of interest of the drift and boreholes, and then here you can see the solution for temperature, liquid pressure, and displacements. We have considered one of the boreholes, and we have made a comprehensive sensitivity calculation. The results for the sensitivity analysis are very important for the performance assessment studies. In this case, you see that temperature, liquid pressure, and stress is highly sensitive to, for instance, presence of fractures, properties of the rock, presence of gaps, whether the gaps are empty or are backfilled with pellet materials. So different engineering related aspects that can change from one zone to another, and even in the same repository. In this context, there is another research line which is related to the gas migration in the clay-based materials. This part of the presentation describes an experiment that has been carried out at the British Geological Survey and is investigated to understand and characterize the material with respect to gas flow. You see that in this case there is an inflow protocol, and then that produces some pressure increment. That pressure increment develops flow, then flow manages to outflow on the other side of the sample, and stresses develop. This flow is characterized by formation of preferential paths, so it's not only by diffusion and advection, but it's necessary to have some development of preferential paths to permit the gas to flow through the sample. To prepare the model, in addition to the representation of the sample itself, we need to add some specific features because it's a very complex model that filters and additional elements of the experiments play a role because they have some volumes that are attached to the sample. And then it's important to do this representation in a correct way. This picture shows that there are some sensors that are connected through pipes, and then this represents a volume that is attached to the sample, and this has to be considered to produce a correct modeling. The sample in this case is represented by some heterogeneity. Heterogeneity is quite sophisticated. It's not that some properties are heterogeneous, but A function of permeability, depending on the deformations, has heterogeneity incorporated, and then some parts of the material might undergo some permeability variations, and that is interesting for the modeling of the preferential paths for the gas flow. Then gas penetrates in the sample at the beginning by diffusion. Then there is some water displacement, and finally, at some point, there is a breakthrough, and gas can flow from the inflow point to the outflow point of the sample. And then, if you see in our model, we can represent some preferential paths, and the model is able to capture this type of feature of kind of formation of preferential paths through the sample. The results of the model in terms of flow rates, pressure, and stresses can be compared with the measurements, and the results are quite satisfactory. And the model permits to understand what are the main type of mechanisms for flow depending on the part of the experiment. At the beginning there is diffusion, as I said, then there is some advection through the liquid phase as the water is displaced, and then in a third phase there is a formation of a gas phase, and that gas phase permits the gas to flow by advection. As I said, this is by a preferential path. This is very much connected. The interpretation of these gas flow mechanisms is very consistent with what happens in the boundary conditions of inflow and outflow. A comprehensive sensitivity analysis has been carried out in order to permit the calibration of the model. Properties of the material and properties of the laboratory equipment have been calibrated, and then at the end the good solution that has been presented has been reached. The models and parameters, we are using them for large scale calculations, and for instance here you can see a tunnel in which excavation of the rock has been carried out, then installation of the different components including 3 heaters representing the waste disposal have been installed, and then heating starts and water flow and the formations are modeled. This is a work we are doing for the Swiss Agency of Nuclear Waste Disposal, NAGRA. Thanks for your attention, and Codebright, you can find information in the social networks and web page. And we organize courses, we have material available, and we are happy to help people to use the program.